Go on and get started with today's lesson. Now, we're going to do two of each type of problem that we're going to look at today. Now, what we're looking at is law of sines. Now, there's three main laws with sine and cosine and tangent. One's going to be called law of sines. There's going to be one called law of cosines, and the third one is law of tangents. Now, sine, what we've worked with so far, there we go. Sine of an angle was equal to opposite over the hypotenuse, the opposite side length over the hypotenuse, and that's what we went over in chapter 9 so far. But this works only if we have a right triangle. Okay. So this here only works if it's a right triangle. But are all triangles going to be right triangles? Well, no. Have a right angle. Now, law of sines works for any and all triangles. So even if it is a right triangle, these properties still hold true. And there's two different versions of this equation. They are the exact same equation, just one is a flip of the other. Sine of A over A, sine of B over B is equal to sine of C over C. We really use this one here to find a missing angle. A over sine of A is equal to B over sine of B is equal to C over sine of C. We really use this one to find sides, a missing side. And for any one, whenever we use this, we only use two parts. A over sine of A over sine of B is equal to C over sine of C. And this here is for our sides. If we're trying to find a missing side, we're going to use this equation here. This setup here. If we're wanting to find missing angles, we use sine of A over A is equal to sine of B over B is equal to sine of C over C. And really, we're just using the side and the angle opposite for any one of these three fractions. So A is going to be over sine of A, the angle opposite side length A. B over sine of B, side length B over sine of the angle opposite, which would be angle B, and the same for C. So we use sines. When sine is on top, we're really trying to find an angle. When the letter's on top, we're trying to find a side length. And this here is a lot easier than you might think, because a lot of this is actually going to be done in the calculator. We're going to be using some steps to solve it to get the variable that we want by itself, and then we're going to plug the rest of it in. Now, these first two that we're looking at, we are given two angles and a side. So we need to find the angles. We need to find all the missing angles and all the missing sides. Well, here we're only missing one angle. And any three angles in a triangle add up to B. So to find this missing angle A, we can add the two other angles together. So 107 and 25. Because once we add them together, we can then subtract that from 180 and get it. So this here is 132. And if we subtract 132 from 180, exactly, we would get 48. So part of our answer here is finding the measure of angle A, which is 48 degrees. Now we need to find side length A and side length C. Any questions on this so far? Okay. I'm going to erase this here so we don't have so many numbers up on the board. Now, here we're trying to find a missing side length, yes? So for us to be able to solve this here, we're using our A over sine of A is equal to B over sine of B is equal to C over sine of C. And we only use two parts. So on this here, I'm only going to use either these two here, the two fractions, or these two here, or the first and third. We only need two of them. Now let's see what's given here. Well, we need to find A or C. Which one do y'all want to find first? A. Now, A, according to this formula, is going to be over sine of angle A is equal to, well, not quite yet, but we can eventually. Now, we do need to know another side length. Well, the only one that's given to us is 15, yes? And that would be our B over sine of B, yes. Because I'm just rewriting it for this way because I'll do it this once and then we'll actually just do straight to the numbers here. Now, the reason we're using B is because it gave us the side length of 15. It actually gave us the side length over sine of the angle opposite B is opposite side length of 15 is 25. So B over sine of B. B is the side length 15. The angle opposite is our 25. Now we started off with finding A. Now our angle opposite A is 48. So the angle under that goes inside sine under A is 48. So we would have A over sine of 48 is equal to B over 15 over sine of 25. So we plugged in angle A because it's this angle opposite side A. We plugged in the side length of B, which is 15, and the angle opposite B, which is our 25. Questions on this here? So really, we just plugged in the values that were given to us. Now to solve, we need to get A by itself. And to do that, we're going to multiply both sides by sine of 48. Now the reason we're multiplying both sides by sine of 48 is because over here, it would multiply with the numerator, telling us that we have A sine of 48 divided by sine of 48 is equal to 15 sine of 48 over sine of 25. Well, anything divided by itself is 1. So really what it's telling us is that over here we have A is equal to 15 sine of 48 divided by sine of 25. Well, 15 sine of 48 divided by sine of 25, that's just a number, isn't it? So on the calculator, fraction, we could say 15 sine of 48 over sine of 25, and hit enter. And I believe it says we're going to the nearest tenth. So we're going one decimal place. So 26.37 would become 26.4. And that's the value of A. Yes. Now this middle step here We won't have to do this every time, especially writing sine of 48 over sine of 48. Again, I wanted to do it at least once so we can see that they would cancel out. Any questions on this here so far? Now we just need to find what? C, yes? Exact same steps. It's just the exact same thing. Now, I will show you a little bit of a shortcut that does help, especially typing it into the calculator. Okay. Now, I'm going to erase this here so I have a little bit more room. Now this time, we're going to still set up the same setup. We're going to have our two fractions. This time we're trying to find C. Now C is going to be over sine of angle C, which would be our 107. And this is equal to, well, we do now have two side lengths because we've said A is 26.4, yes? I'm going to still stick with 15. And 15 would be over sine of 48, yes? Okay, so we typed it in. Are we good with this here so far? Now, we did skip a few steps because we didn't rewrite it as C over sine of C is equal to B over sine of B and then plug it in. And I did that originally so that we could see how does this connect? How do they work together? But now that we kind of see that, we can just go on and plug the numbers in. Now, to solve this, we're going to multiply both sides by what? Sine of 107 by the bottom of our fraction over here. And as we saw earlier, these two here would actually cancel out. It actually tells us that C is equal to 15 sine of 107 over sine of 48. Any questions on this so far? Now, the reason I picked 15 and sine of 48 is because if we look back at the calculator, what we typed in previously does have the 15 in the numerator and sine of 48 still in the denominator, yes? But we can bring that back down. Because if I go up and highlight it and press enter, it'll copy it back down, because the only real difference between what we typed in the first time and what we need to type in now is that I don't need 108, or I don't need 48. I need what? 107. So I can replace one number with 107. And I get the answer. Now, we could have used A over sine of A, but we would have to retype the whole thing back in. Any questions on this here? So 33.94 or 33.9. Mm-hmm. 25. Ah, that's why, because opposite 15 should be, thank you, because this here shouldn't be 48, it should be 25. That's my fault. Got to the right answer, but had the wrong number written down. Probably would confuse you why those split a little bit. Yeah, no, that was me writing it down wrong. Huh? Well, that would be needing to distinguish between a typo and a actual error. So the last part of this is that this here is 33.9. So that there would be our answer. Questions on this here? All right. Let's look at one more of these to kind of get a little bit better handle on it. And realistically, we're doing the same, essentially, steps to find the two sides. Now for this one here, we need to find the missing angle because they give us two angles and a side. So we need to find one angle, which would be the measure of angle B. And then we need to find the side lengths of B and C. Because once we find these three values, we are done with this problem. Now, because it gave us two angles, well, we can add these two angles together and then subtract it from 180. So if we add 115 and 38 together, 153. And if we subtract 153 from 180, we get 27. So that tells us that the measure of angle B is 27 degrees. Now we just need to find the measure of angle B or C, well, B and C. We'll just need to decide which one we want to find first. We can do B first. So B over sine of B. Well, the angle opposite side length B is 27, or really the angle attached to angle B is 27. Now we're actually only given one other side length, which is 25 over sine. Well, the angle opposite the 25, the length of 25 is 38. Any questions on how we set this up? Well, now we need to get B by itself, so we would multiply both sides by sine of 27. And here, these two will cancel out, telling us B is equal to 25 sine of 27 over sine of 38. So we can type it in as 25 sine of, I'll grab a note sheet. Just trying to remember these is of 27 over sine of 38. And if we type that in, we would get 18.43, or to the nearest tenth would be 18.4. And that'd be the value of B. Any questions on this here? Now to find angle or side length C, we do the same thing, but with C. Am I good to erase this here so that y'all can still see it? So here we would have C over sine of the angle opposite side length C, 115, is equal to, well, we can still use our 25 over sine of. Now at this point here, we would multiply both sides by 115. These would cancel, telling us C is equal to 25 sine of 115 over sine of 38. Again, we can kind of use a little shortcut of going up, selecting it, and bringing it down. And changing the 27 into 115. And if we hit enter, it tells us that it's 36.8. And that's it. Questions on this here? Not too bad. Because really it's setting it up, multiplying by one thing and plugging it in. Any questions on this here? All right. Okay. We're going to skip a 2 and go look at this one here. This one's a little bit different because this time it only gave us how many angles? 1 and 2 side lengths. So this time I need to find the measure of angle C and the measure of angle B. And then find side length C. But really, once I find one of the angles, I'm actually given the other. Because any 3 angles in a triangle have to add up to B. So once I get 2, I can add those together and subtract from 180 to find the third. Now the setup we're using for this here is the other version of this equation. So we're using like sine of A over A is equal to sine of B over B is equal to sine of C over C, where we're using the angle on top and the side lengths on bottom. And interestingly enough, we actually can use this here. Because the one angle they actually gave us is 82. They gave us A. And what is the side length opposite from A? Okay. So we used one of the side lengths in the only angle, yes? What was the other side length they gave us? And it would go in bottom of the other one. And then we'd have sine of the angle opposite that side, which is actually, we can call it X or we can call it B since they actually named the angle B. Any questions on this here? Now in the previous one, we multiplied both sides by the bottom of the fraction of what we wanted to solve for. Well, we'll do the same thing here. This time we're just multiplying both sides by 24. And we do this because, well, this 24 and this 24 will cancel out. And that will tell us that angle, or sine of B, is equal to 24 sine of 82 over 29. Now, unfortunately, at this point here, the angle isn't by itself because we have sine of b. Now, we did go over a method to get the angle by itself, and that's using our sine inverse, because sine inverse and sine of b simplify out, leaving us with b is equal to sine inverse of 24 sine of 82 over 29. We have to apply sine inverse to both sides. Now again, at this point here, we could type this whole thing into the calculator. So we can say second sine inverse of 24 sine of 82 over 29. And we can hit enter. So we get 55.037. We can round it to the nearest tenth, which would just be 55.0. So it tells us that B 0.055. We could, yes. But any three angles in a triangle add up to be what? So we can actually, yeah, we can add them together. Which would tell us that this is 43 degrees. Any questions on this here? Well, we're still missing what? C, yes? Yes, if it's a right triangle. It's not a right triangle, but we already know what we're going to do. We're going to do what we just did on the previous problems. Because our missing side length C is going to be over sine of is equal to, I need a side length, 29 over sine of. So we're going to do the exact same thing we just did on the previous problem to find C. So we're going to multiply both sides by. And these here will cancel, telling us C is equal to 29 sine of 43 over sine of 82. Now, unfortunately, unlike the last problem, we can't just select it and bring it back down because the previous thing we typed in had sine inverse. We'll actually have to type the whole thing in. Fraction 29 sine of 43 over 29, yes? 82. Thank you. And it was in the bottom, wasn't it? I do better when I'm looking straight at it. 29 sine of 43 over sine of 82. 29 sine 43 over sine of 82. 19.97. If we rounded it to the nearest tenth, the 9 would become 0, and we would get That's it. That's all we have to do to solve for the missing side and two angles. Any questions over any of this here? Do we need to see another example of one of these? If we're good with this here, there is a worksheet that is attached to this. And it is a staggering 4 problems. So 2 of the problems, the front 2, you're having to solve for an angle and 2 sides. The 2 on the back, you're having to solve for 2 angles and a side. Number 4? Yes, I have it checked out to you. 20? 10? Yes. Now, in the pre-calculus class and trig class, we go deeper into this one because there is what they consider the ambiguous case. For given 2 sides of an angle, it might not always work out.